Now this one's number 26, and it's just one step away from being number 24. But I'm going to split up the radicals. And then, again, I'm trying to rationalize my denominator. Why? I don't know, sometimes it's actually very useful. There's a trick, but you don't get to see why it's useful until like way later on in like other classes. So I guess we're just practicing. Sorry. All right. So here, I notice that 4 breaks down to 2 times 2, which is 2 squared. But I would love it if it was 2 cubed. So I have 2 squared. This part is 2 squared. Maybe I'll write that. So that's that. And then the cubed part there, 2 squared. And then I want it to be 2 cubed, so I'll multiply by another cube root of 2. And I have to do it in the top so that I'm actually multiplying by 1. And then what do I get? I get 14 in the top, cube root, divided by 2 cubed now. But that's underneath the cube, so it just becomes a regular 2, and it becomes that easy. Now you can't do 14 divided by 2. Remember, it's got to be in the same radical. But there you go. That's rationalized. Now the denominator, it has no more radical. All right, let's do 28. Yeah, we could do it in the same video. Number 28. So what do we have? Oh, geez, 1,296. Divided by 25. Well, I already know that 25 is 5 squared. So I must need another 5 squared, because if I have that, it would add up to 4. Oh, interesting. So let's rewrite this. 1,296. Well, 1,296, and that's 4 there. And, well, I have, that's just 5 squared under the 4th root, and then I'm going to do another 5 squared under there, and I have to do it in the top as well. So I have that 5 squared, and that, I see, this will be 5 to the 4, and then that will cancel out to just regular 5, and this is 25. Times, that's quite a bit. That's quite a large number. That's such a huge number. Maybe I can reduce that. I wonder if I could. 3, 2, 4, 0, 0. I'm just going to start dividing by 2 and see what I get. Divide by 2. So this is actually 2 times 1, no, 16,200. I can divide that by 2 further. So I will do that. Divided by 2. And that equals 8,100. I can divide that again by 2. And I get 4,050. One more 2. I could. Yeah, divided by 2 equals 2 times 2,025. So already I have 2 to the 4th. So I'm going to save that. 2 to the 4th. And then I bet I could divide it by 5. I bet I could divide it by 25. Divide by 25. Yep, that's 25. 25, and that becomes 81. Okay, that's nice. What happens then? Well, that doesn't matter. Well, see, look at this. This is what I'm thinking. I have 2 to the 4th on the inside. And then I have 5 to the 2nd on the inside. And I have, because that's 5 to the 2nd. This is 9 squared. 9 squared on the inside, right? Oh, actually, no, wait. That's 3. Divide by 9 and 9. If I divide it by 5, nothing happens. So that's fine. But this becomes 3 and 3 and 3 and 3. So really what I have is 3 to the 4th. That's beautiful. That's beautiful. And what do I get? Okay, so it was this. This is confusing. It's okay. It's okay. We get it. We'll get it. And then that was, what, a 4th root? So all of that underneath a 4th root. Well, that's the same thing as the fourth root of 2 to the 4. Fantastic. Times the fourth root of 5 squared times the fourth root of 3 to the 4. So what do we have? That goes away. Great. That goes away. Another fantastic thing. And then, this I can put back. This would be 2/4. Yeah? Yeah, I think so. And that's just a regular 3. So that and that is great. That would be 6. And then this is just 1/2 times 5 to the 1/2. And then I still have my 5 on the bottom, right? My 5 on the bottom. But 5 to the 1/2, I know what that is. That's 6 times the square root. Regular square root. What? We went all the way back down to a regular square root. And we have that. I don't expect you to get this on your first try, so I'm going to be done now.